Hello everybody, I'm Miss G and I'm going to try to make math a little easier for you today. In this video we're going to be talking about inverse trigonometry, which is the process of figuring out an angle when you have two sides on a right triangle. Inverse trigonometry is the opposite of trigonometry, where you use one side and one angle to find a second side. They're usually treated as the same process with extra steps, but I like to think of inverse trigonometry as its own set of formulas because I find it easier to solve if you're just aware of what you're looking for and start at that point. One of the most beneficial things we can use for trigonometry is SOHCAHTOA because it tells us your formulas. Sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. So for a problem like the one here, our angle is G and our two sides are this 8 and this 4. The 8, because it's across from our right angle, is our hypotenuse, and if we went toward the angle we're using, that side would be our adjacent, but this side doesn't have anything on it, so I'm not worried about it. That leaves us with our third side, our opposite, which in this case is going to be useful to us. The two sides we have are going to be opposite and hypotenuse, which means I know I'm going to use inverse sine. This -1 here is what makes it an inverse as opposed to a traditional sine, and we'll end up using the formula opposite over hypotenuse to figure out the value of the angle. Let's take a look at our three formulas to start with. We have inverse sine of opposite over hypotenuse, which would use the 4 and the 8. We have inverse cosine adjacent over hypotenuse, which would use this unknown side and the 8. And inverse tangent, which would use the 4 and the unknown adjacent. Now, cosine and tangent are both functions we could use here, but only if we started with our Pythagorean theorem. A squared plus b squared equals c squared. We could set up adjacent squared plus 4 squared equals 8 squared, solve for our adjacent, and then have a value to use in cosine and tangent. However, I'm far too lazy to do all of that extra work when I already have a function that uses opposite and hypotenuse, and that's going to be sine. The goal of inverse trigonometry is always to figure out an unknown angle when you know two of the sides. And there are 5 steps to the process. We start by identifying the angle we want to use and labeling the sides that we have. So in the last case, we had opposite and hypotenuse, but you might have any 2 of the 3. Sometimes you have all 3, and then you can just choose a formula and it doesn't matter which. Then, once you have everything labeled, you'll choose your function. If you have opposite and hypotenuse labeled, you'll use sine. If you have adjacent and hypotenuse, you'll use cosine. If you have opposite and adjacent, you'll use tangent. And if you really want to use tangent, but you have opposite and hypotenuse, then you can use the Pythagorean theorem to figure out the adjacent and use tangent that way. Or if you have all 3 sides, then you just pick a function and use the sides that it needs. Once you've picked your function, you'll plug in the 2 sides you're using, and then you'll use a calculator to find your answer. For inverse trigonometry, we generally round our angles to the nearest degree unless we're told to do something else. So let's put that together for this example. Here we have our angle, which is marked with a question, in this corner. We also have a number here and a number here. So these are the things that I'm going to want to mark. The angle doesn't need a name, but the sides do. So I'm going to start going from the corner of my right angle across, and that's going to be my hypotenuse. So I know I'm either going to use sine or cosine since tangent doesn't use the hypotenuse. This other side we're using goes from the box away from the chosen angle, which means it's not the adjacent. And if it's not the adjacent, that makes it the opposite. And that narrows it down to sine. Again, though, I could use cosine or tangent if I wanted to, but I'd have to use the Pythagorean theorem to figure out my adjacent first, and I'm really not willing to do that. So I'm going to use sine simply because it has opposite over hypotenuse. And I know that because SOH stands for sine of opposite over hypotenuse. All I'm going to do at this point is plug in my values. So I have inverse sine of my opposite, which is 16, over my hypotenuse, which is 20. And then from here, I need to plug it into a calculator because the reality is I can't solve this without either a calculator or a table of trigonometric values. I'm going to use the calculator at desmos.com/scientific because it's a really good calculator and it's available to pretty much anybody. The first thing I need to do on my calculator is find inverse sine. On Desmos, we go to the function pad and then we hit this sine -1. That's our inverse. If we were using regular trigonometry, we would hit regular sine. And then once we have the trig function, we go back to main to type in our numbers. So I'm going to go 16 divided by 20 to put the fraction in there. And then I have my answer, 53.13, and so on. But, as I've said before, we normally round angles to the nearest degree, and that would mean this is either going to be 53 or 54, because 53.13 is somewhere between those two numbers. Now, 53.13 is somewhere over here, which means it's much closer to 53 than it is to 54. So my answer is approximately 53 degrees. For this next one, we're going to follow those same steps. We start by marking the things we've got. We have a 6 on this side, we have a 9 on this side, so those are the two sides we're going to use, but we don't currently have an angle on the picture. That's where the question stem comes into place. We have our question, determine the measure of angle A to the nearest degree. So we want the measure of angle A. So I'm going to put a question mark inside angle A, just because it helps me to visualize. From here, I'm going to label my sides. Normally I would label my hypotenuse, but it doesn't have anything on it, so I'm going to skip that. Then I'm going to go toward the angle I've chosen, and that side is going to be the adjacent, and the remaining side will be the opposite. Looking at SOHCAHTOA, of my three options, the one that uses opposite and adjacent is tangent. So my formula is going to be tangent, specifically inverse tangent, of opposite over adjacent, and that's going to equal my angle value. Just like before, all I need to do is plug in my numbers. So we'll have opposite, which is 9, over adjacent, which is 6, and we'll plug that into a calculator. We'll start by hitting function, then inverse tangent, then back to main, and hit 9 divided by 6 equals. And that gives us 56.30 and so on. That puts our angle somewhere between 56 and 57. And 0.3 would be somewhere here, which means it's closer to 56, giving us an angle value of approximately 56 degrees. Although for this problem, I would actually write the answer as the measure of angle A equals 56 degrees, because it's always a good idea, if you're given a specific question, to repeat the question in the answer to make it clear that everything's connected. Here again, we have a question mark and an angle, and we want to round to the nearest degree. So I'll start by marking the things I know. We've got a 7 on a side, a 24 on a side, and an angle that we're looking for, because this question mark is really this right here, but it's just too tiny to fit. So I'll start by labeling my sides. My hypotenuse would be here, but it doesn't have anything on it, so that's not useful. My adjacent goes to the angle I'm using, so that's going to be this side here. And my opposite is the remaining side. So I'm using opposite and adjacent, which means once again, I'm going to use inverse tangent, because according to SOHCAHTOA, sine uses opposite and hypotenuse, and we don't have the hypotenuse. Cosine uses adjacent and hypotenuse, and we don't have the hypotenuse. Tangent uses opposite and adjacent, and those are the two sides that we have. If I wanted to use my hypotenuse, I could use the Pythagorean theorem to solve for it, but I'm not willing to do that kind of work. Now, inverse tangent uses opposite over adjacent, T, O, A, and I'm just going to plug in my values. So we have inverse tangent of opposite, which is 7, over adjacent, which is 24, and that's going to equal our angle, whatever our angle is. Then we plug that into a calculator. Inverse tangent, main, 7 divided by 24. And that's going to give us 16.26 and so on. That means that our angle value is sitting between 16 and 17, and 16.2 is somewhere over here, which puts it closer to 16, giving us an angle measure of approximately 16 degrees. For this last example, we're asked to determine the measure of angle E, so we want this corner here. We also have a number on this side and a number on this side, and we'll start off the problem by labeling them. The 14 is across from the right angle, making it the hypotenuse. The 7 is between the right angle and the angle that we're using. That makes it my adjacent. And since I have adjacent and hypotenuse, according to SOHCAHTOA, the only trig ratio that uses both adjacent and hypotenuse is cosine. So we have inverse cosine of adjacent over hypotenuse because we have CAH, and we'll just plug in our values. Inverse cosine of adjacent, which is 7, over hypotenuse, which is 14. And now we need our calculator. We hit our function key to get our inverse cosine, and then we go back to our main to get our number pad, and we do 7 divided by 14, and that's going to equal 60 degrees exactly. Now for this one, I don't need to worry about rounding because it's exactly 60 degrees. There's nothing to round. It's already marked to its nearest degree. So the measure of angle E equals 60 degrees, because again, it's always a good idea to put the question in the answer whenever you can. I hope that made inverse trigonometry a little bit easier for you. If you want to help me out and hit those like and subscribe buttons, I would greatly appreciate it. But if not, I still love you. I hope you're having a fantastic day. Bye, everybody!